Okay, Abby, this is lesson 69. So basically, lesson 69, it's about gas law problems. So any problem that starts off with an amount of or a quantity of an ideal gas. Those are the key words you're looking for. If it says ideal gas, you're going to use the formula P1, that's the first pressure, times the first volume divided by the first temperature is going to be equal to, this is a proportion, the second pressure or the final pressure, the final volume, and the final temperature. Okay, that's always going to be the formula that we use. The initial pressure times the volume divided by the temperature is equal to the final pressure times the volume divided by the temperature. Every single time. Okay, so the first problem that we have here says a quantity of ideal gas. So this is going to use this. So all you have to do, you find that and you go, okay, I'm good. I know what formula I'm using. Then it tells you the order of the values it's going to give you. And it says it's going to give them to you pressure, volume, and temperature in that order. So the initial pressure is 50 times 10 to the third power. So we put that in first. 50 times 10 to the third power. Just write it the way it gives it. And then you have 0.008 times 10 to the negative 4 for volume. And you know it's volume because it has an exponent of 3 on a unit of measure. Okay? This is cubic centimeters. So that's volume. So we write that in here. You don't have to put the unit of measure. And then it gives you the temperature. K means Kelvin. And Kelvin is a measure of heat energy. So when you see K, you know it's temperature. Okay? So 300 times 10 to the fifth power. 300 times 10 to the fifth power. So that's our initial pressure, volume, and temperature. So now we have the final, we're looking for the final temperature. So that's the one we don't have. If the pressure was this, I'm going to make this line longer, 0 point, and that's 1, 2, 3, 4 zeros, 1, 2, 3, 4, 5 times 10 to the 14. And then this one is 1, 2, 3, 4 zeros, 0.123414 times 10 to the negative 8. And that's volume because it's centimeters cubed as well. Okay, so I'm going to stretch this out so we can solve this problem. It's going to take a little bit more space. So now we can see everything. We know from our previous lesson last semester that this is not in proper scientific notation, because we're only supposed to have a ones place value. So we've got to adjust all of these in the first step. So this would not be 50. It would be 5 times 10 to the something. And if we move the decimal forward 1, we're going to add 1 here. So that makes that a 4. And we know the decimal is going to be behind the 8. 8 times 10 to the something. So 1, 2, 3 spaces backwards. And backwards is negative progress. So that's going to be negative 4 and negative 3. That'll be a negative 7. We know this is going to be 3 times 10 to the something. 1, 2 to the front of the number. So that's forward progress. So we add 2. It's 10 to the 7th power. All right, so there's our initial information put in the right format. Now we have to do the same thing over here. So the first number I see is a 5 times 10. And we're going to go backwards, so it's negative progress. 1, 2, 3, 4, 5, so minus 5. 14 minus 5 is 9. And now we have 1.4 times 10 to the something. 1, 2, 3, 4, 5 backwards. We're going backwards, so minus 5. Negative 8, negative 5 is a negative 13. And we still don't know what the final temperature is. But now we can solve it a lot easier, right? We got rid of all those zeros. Now we can use real numbers. So 5 times 8 is 40 times 10. And we have 4 and a negative 7. That's going to be a negative 3 over 3 times 10 to the 7. Now, that's its own value. We have 5 times 1.4, which would be 5, 6, 7. I think that's going to be 7. Let me make sure. 5 times 1.4. Yeah, okay, so 7 times 10, 9, and negative 13 is going to be a negative 4. And then we have T2. Okay, so there's a couple of different things you could do logically to solve from here. We could divide this, right? And then multiply both sides by this unknown variable, and then divide by this. We could do that, and we would get to the same answer, but it's a lot of confusing steps. It's a lot easier to solve when you have a fraction and a fraction just by cross multiplying. So that's going to give us the same thing anyway. T2 times 40, and actually what I'm going to do is I'm going to go ahead and put this in proper scientific notation. So that would be forward 1, so plus 1. So 4 times 10 to the negative 2. All right, so that's going to, I've swapped that out after doing that multiplication. And now this is in proper scientific notation form. And then this is going to be 3 times 10 to the 7th times 7 times 10 to the negative 4. Okay, so now we have some values. So we have this times this is equal to 3 times 7 is 21, times 10, 7 minus 4 is 3. Now, if I move this decimal forward 1, that's going to be 2.1 times 10 to the 4th power. So 2.1 times 10 to the 4th power, because it was 21 and we need to put it in the right format, so we added 1 when we move the decimal forward. Okay, so now that we have everything as succinct as possible, we have a variable times a number. We're going to divide both sides by the number that we know. Okay, so then this cancels. So the final temperature is going to be this number divided by this number. So I'm going to do that. 2.1 divided by 4 is 0.525 times 10. We're going to bring this to the top, so plus 2. So that's 6. However, this is not proper format, so the final temperature, we're going to move this back 1, be 5.25 times 10. We moved it back 1, so back 1 to the 5th power. Okay? That's how we solve these things. We put them in the proper format, right? To make them, get rid of all those extra zeros. Once we have that in the proper format, then we can just cross multiply. Do any calculations that are in the numerator first. Then when we have one value, one value, one value, one value, we cross multiply, put everything into the proper format again, and then do the calculation, whatever it might be, and then reformat whatever the answer is into proper scientific notation format. So that should be the right answer. I'm going to type it in over here to show you how to type it in. Okay, so that'd be 5.25. We're going to use this x times 10. We're going to use the exponent of 5, and then that should be correct. It's not correct. I don't know why it's not correct. Let me see what's going on. Oh, I forgot the unit of measure. Okay. So, yeah, that was bad on me. I forgot. You've got to put the unit of measure of whatever it is out there. We got the right answer, but temperature was, looking at the problem, temperature was Kelvin. So I forgot to do that. I am so sorry. So now, if we put Kelvin out there, 5.25 times 10 to the 5th power. And then we get out of that. You saw how I got out of that blue box. And I'm going to type a capital K for Kelvin. Now it's right. Okay, so the math was correct. But you've got to put in the unit of measure. It gives you the unit measure for all of them. So you've got to carry that through and use it in your answer as well. It's important, right? Otherwise, it's just a number. We've talked about that before. So that was bad on me for forgetting that part of it. That is the answer. So that's how you're going to do all of them. You're going to, for this next one, let me shrink this back down so we can see what we're doing. For this next one, you would set it up the same way. The initial pressure times the volume. You can use P1 V1 over T1, just to remind you that this is the initial. And then this is going to be the secondary. It's always going to be that. Every time you see ideal gas, it's always going to be that. The main thing I want you to pay attention to is that there's no guarantee that this is going to be in the same order as what you need to drop it in. So pay attention to the order it's written. That is the order it's going to give it to you. Also, pay attention to the unit of measure, because the unit of measure is going to tell you what it is, whether it's pressure or volume or temperature. Right? Anytime you say unit of measure with a 3 on it, that's volume, right? Inches cubed, feet cubed, yards cubed, miles cubed, centimeters cubed, meters cubed. All of those, right? That's going to be your volume. And then K is typically temperature. Usually you're not going to see Fahrenheit or Celsius. I'm not going to say you won't, but typically it uses kelvins. So the K is temperature. And atmospheres, just think about a balloon pressure from the inside of a balloon pushing on the outside of a balloon. What's inside of the balloon, that pressure, that whatever it is that's inside of that, is an atmosphere. That's the balloon's atmosphere pushing out against the balloon. So that's the pressure. That's how you blow up a balloon, is by when you push the air into it, it creates pressure that stretches the balloon. And that internal air of the balloon is its atmosphere. So this, you can recognize that as pressure. Just saying. Okay, so that's all you're going to do. You're going to take these numbers and you're going to put them into the proper scientific format. And I like to go ahead and do that as I write it down. So this is the pressure. So 80 times 10 to the 5th power. Okay, we can't have 80. It has to be 8. So 8 times 10 to the something. So I went forwards 1. So I'm going to add 1. So it'll be 5 plus 1 will be 6. So that's that first number. Second number, first whole digit I see is 5 times 10 to the something. So this is going backwards. 1, 2, 3, 4. Negative 7 minus 4, that's negative 11. Over. All right, so this is going to be 8 times 10 to the something. And this is going to go forward. 1, 2. So 5 plus 2 is 7. Okay? And that's going to be equal to we're going to find the final temperature. So this is the one. We're not finding this one again. These numbers look awfully familiar. No, they're different. Okay. Okay. I was thinking they were very familiar, but they're different. Okay, so final pressure is going to be 8 times 10. Let me stretch this out a little bit. 8 times 10. And this one is going backwards, so negative. 1, 2, 3, 4. So 16 minus 4 is going to be 12. And the final volume will be 1.3 times 10. And that's going to go backwards 1, 2. So minus 2. Negative 12 minus 2 is a negative 14. All right, so we've got everything in scientific notation now in the proper way. So one of the ways that makes it easy for me to think about this, makes it easy for me to solve these, and I don't want to confuse you at all, but I like to think of times 10. That times 10, this is a base. Like it's like a variable with an exponent, right? It's like a variable with an exponent. So instead of writing this out every time, I substitute in the letter t. So what we really have here is 8t to the 6th power times 5t to the negative 11 over 8t to the 7th power equals 8t to the 12th power, and then 1.3t to the negative 14 power over T, the final temperature. So that makes it easier to treat these like variables because they look like a variable. And that's really what we're treating this times 10. We're not really even worried about what its value is. We're treating it like a variable and just writing it out. But all of these numbers, times 10, times 10, times, that can get really confusing, and it can really be distracting as well visually. So that's why I like to substitute these 3 letters or these 3 characters with one character that means the same thing. And at the end of the problem, I change it back. So for me, now that I see this, right, these are all factors. So it's the same thing as getting rid of. I can actually get rid of the parenthesis now. You know, because they're all factors. Let me see if I can get this smaller one here. I can actually get rid of the parenthesis, understanding that. So that makes it easy for me to reduce and factor as necessary. Right? So seeing that now makes it really easy for me to factor out my 8s, right? And then I can say 6, this is going to be 5t, 6 minus 11 is going to be a negative 5 over t to the 7th, right? And then that's my most reduced form. And now I've got, and actually we know that's a 1t, right? Because we factored it out. It's 5 over 1, right? There's always that invisible 1 in front of the t, so don't let that confuse you. And now we've got 8 times 1.3. That's going to be 8 plus 2.4. So it's going to be 10.4. T, 12 minus 14 is a negative 2 over final temperature. That's just a way of simplifying the process. Now it's a lot easier to see what's going on. So we've got 5t to the negative 5 times the final temperature. And we've got 1t, 1t to the 7th power times, I'm going to change this. We're going to go forward 1 space, so add 1. So it's going to be 1.04 t to the negative 1. 1 times 1.04, just going to rewrite this right quick. 1 times 1.04 is 1.04. 7 and -1 combined together is a 6. So now I just need to divide both sides by this. 5t to the -5, 5t to the -5, right? This cancels this. So the final temperature is going to be 104 divided by 5. 1.04 divided by 5 is equal to 0.28. We know we need to have a whole digit, so we back this up 1. So we're going to subtract 1 from the answer. So that's going to be 2.08, and we're going to go ahead and subtract 1 here. Then we're going to take this up to the top, make it a positive 5. It's going to be 5 plus 5. It's going to make this times 10 to the 10th power, because I substituted the t for times 10. But you must admit that that solves a whole lot faster and a whole lot simpler than writing times 10 times 10 times 10 times 10 every stinking time. And because it's the final temperature, our unit of measure is kelvins. So let's type this in and see if we are correct. 2.08 times 10 to the 10th power. I'm going to get out of the box and type a capital K for kelvins, and we're correct. So that's just a method to keep you from having to write times 10 times 10 times 10 times 10 times 10 every stinking time. You can switch it over to the T. Just remember to switch it back at the end of the problem once you have solved completely. Okay. All right. I don't want to confuse you entirely. I really don't. That's not my point. So I'm going to do another one. And again, it's the same. It says ideal gas right here, so we know it's the same formula. So we have the initial pressure times volume over temperature. This is the P1, V1, T1. And then final pressure times volume over temperature. So final, 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 P2, V2, T2. Okay, the initial pressure, volume, and temperature of a quantity of ideal gas were these, and these, and these. What was the final temperature? Again, we're looking for temperature. So this is going to be the one that we're looking for, is the final temperature. So let's go ahead and put in proper scientific notation our initial values. So this is going to go backwards, 1, 2, 3 spaces. So -3, that's going to be 1 times 10 to the -16. And then back 1, 2, so -2. It's going to be 4 times 10. 14 minus 2 is 12. And then we have 4, this is already written right for us, 4 times 10 to the 3rd power. We don't have to change that one. Thank the Lord. What was the final temperature? So we know that we're not finding that. We don't have that. I should say we're finding that because we don't have that. The volume, the final pressure and the volume were the same thing. Oh, no, they weren't. Hello. Pressure and volume. Pressure was this, volume was this. I didn't see this. Okay, so we need to write it in proper scientific notation. So we're going to go backwards, 1, 2. So 4 times 10, we go backwards 2. 5 minus 2 is 3. And we got to put this in scientific notation. So we're going to go forward 2. So 5 times 10 to the 2. Okay. All right. So I'm going to take a minute and rewrite it with T's. So 1 T to the -16 times 4T to the 12th power over 4T to the 3rd power equals 4T to the 3rd power times 5T to the 2nd power over the final pressure. Okay, I can factor this out right here. I can combine these And that's going to give me -4, right? So t to the -4 over t to the +3 is equal to 4 times 5, that's 20 t to the +5. And now I need to bring this forward, so I'm going to add 1. So that actually becomes 2t to the +6, because we're going to add 1 right here. That becomes 2.0. Actually, I don't need the 0.0, do I? I can totally get rid of that. T to the +6. So then this all just goes away. And that is over the final pressure. Now that we have it like that, we can cross multiply. And this is easier to cross multiply, right? We could combine them. I could bring this to the top. We could do that, but sometimes it's easier to cross multiply depending on what you have. So t to the 3rd power times 2t to the 6th power is just going to be 2t to the 9th power. And t to the -4 times the final pressure is the final pressure times t to the -4. I'm going to divide both sides by t to the -4. This cancels. And when I bring this up, it's going to be +4. So 2 times 10, 9 plus 4 is 13, to the 13th power, its temperature, so kelvins, is equal to the final temperature. Okay, I know it's kelvins because I can look back in the problem and see the K. So I'm going to type that in here. 2 times 10 to the 13th power, capital K. And that's correct. You see how that can help just by simplifying the problem into, I mean, this is a base. These 3 characters are a base. Just simplifying it into a letter T can help you do the problem so much faster because you're having to write a third fewer characters. Right? Remember how mathematicians are lazy? Well, I guess that makes me a mathematician. But it works for my brain because then I'm not going to write it down incorrectly. I'm not going to transpose something because there's so many characters to have to write every single time. It's easier for me. It does. If it's not easier for you, don't do it. If it confuses you, don't do it. Keep writing times 10 if that's what you need to do. I'm not here to tell you that you have to do it my way. I'm just saying that my way could make more sense and help you make fewer mistakes. If it doesn't, it doesn't. If it does, it does. So do it the way that works for you. All right. I put a little note here. Be sure to use the unit of measure because apparently I had a bunch of students who are getting to use the unit of measure. So we only have this one and 2 more, and then we'll be done. So yay, with lesson 69. So again, same thing. This time though, I want you to solve it for yourself. I'm going to help you set it up. So we've got, this is a little bit different. So the temperature of a quantity of an ideal gas was held constant at 740 kelvins. Whenever it says that one of the 3 things, pressure, volume, or temperature, is held constant, that means it doesn't change. So if it doesn't change, it doesn't affect the proportion. So therefore, we don't have to use it. So that means when the temperature is held constant, your formula is going to look like this. P1V1 equals P2V2. We don't do temperature. If the pressure is held constant, then you would say V1 over T1 equals V2 over T2. You see what I'm doing? Whichever one is held constant, that's the one that is dropped from the formula. So if volume is held constant, it stands to reason, number one, that you can't read my handwriting because it's awful, but number two, that it would be pressure, initial pressure over initial temperature is equal to final pressure over final temperature. So you can see when temperature is held constant, we remove it from the formula. When pressure is held constant, we remove it from the formula. When volume is held constant, we remove it from the formula. So these are the three variations that you're going to have. Okay? So knowing that, now we can go on with this problem. So it says the temperature of a quantity of an ideal gas was held constant. So because the temperature is held constant, we're going to do P, initial pressure and volume, equal to final pressure and volume times each other. So that's what we're going to set it up as. The initial pressure is this. So we have 4, and I'm going to go ahead and use T just to make, that's our times 10, right? T is equal to times 10. 4T, and I've got a -3, but this is not in the right format. So 1, 2, 3, 4. So -3 plus 4, that's to the 1 power. And it's okay if you write the 1 power. We know that it's there by default. But when we're solving these problems, sometimes it helps us to put the invisible 1 there, just for our own sanity. Okay. Now the volume, the initial volume, is going to be 4. And where's my eraser? I'm about to write times 10. 4T. Let's see what that is. So 1, 2, 3, 4 plus 4, because we're moving to the front of the number, forward progress, plus 4 is going to give me a positive 2, is equal to, we don't know the final pressure. That's what we're doing. We're finding the final pressure. So P, you could say P2 if you want. There's not another P, so we're just going to leave it like this, times 8 times 10, which would just be, I'm using my T's here, 8 times 10, so it's to the -2, but it needs to be 8, so 1, 2, 3. So add 3, so that just leaves 1, so T to the 1, right? Okay, so what we can do is we can multiply. 4 times 4 is 16. T1, T2, that makes T3. See how having that 1 there makes it easier to do the math? That's going to be equal to P times 8T1. See how much simpler that is? We know what to do. We're going to divide everything by 8T to the 1, 8T to the 1, right? That cancels. 16 divided by 8 is 2. And this brought to the top would be -1. So we have T to the 2nd power. That is our final pressure. So what we have to do, we have to rewrite this. T2 times 10 to the 2nd power. Now we have to find the unit of measure for pressure. And it looks like this is the unit of measure for pressure. So newtons per square meter is equal to our pressure. So we're going to write it just like that. 2 times 10 to the 2nd power. And we're going to come out here, make a fraction, and put a capital N meters square. And it's correct. Okay? 2 more problems. 2 more problems. We are almost there. Oh, look, these are the easy ones. All right, so we got this one and this one. These are not hard. So we're just going to conjugate this one. We've done a lot of conjugating in the past few videos. 2 minus 3 times the square root of 12. Before we can conjugate this, though, this can be simplified. So you always want to simplify a radical if you can before you conjugate it. So this would actually be 4 over 2 minus, I can pull out square root of 4 times square root of 3, which makes this a 2. So negative 3 times 2 is going to be a negative 6 times the square root of 3. This is what we'll conjugate. Times 2 plus 6 times the square root of 3. All right, so this is not so hard. This is going to be 8 plus 24 times the square root of 3 is our new numerator. Let's see what we get in our denominator. 2 times 2 plus 6 times square root of 3 minus 6 times square root of 3 times 2 plus 6 times square root of 3. That's our distribution. So this times this is 4. This times this is positive 12 square root of 3. All right, this times this is negative 12 square root of 3. And negative 6 times positive 6 is 36. And then we have square root of 3 times square root of 3 is going to be negative 36 times 3. I have no idea what that is. So 36 times 3 is going to be a negative number. It's going to be 108. So negative 108, that's going to be a negative 104. All right, so we've got negative 104 as the denominator. We know we can't have a negative, right? So we're going to multiply everything by negative 1 over negative 1. We can't have a negative in the denominator, so that's going to equal negative 8 minus 24 times square root of 3 over 104. But now I see that we've got some commonality here. And I'm pretty sure that I can divide everything by 8. So let me see if I can do that or not. If I can't divide it by 8, I know I can divide it by 4. So 104 divided by 8. Can I do that? Yes, it gives me 13. So we're going to reduce everything by 8. So it's going to be negative 1 minus 3 times the square root of 3 over 13. That is the most reduced form that we can have. So I'm going to put that in here. Negative 1 minus 3 times the square root of 3 over 13. And that's correct. Last one. All right, so I've got to find all of these. We're going to use the same methodology we've used before and just find something to substitute. I'm given RP and TP, so I'm going to substitute for that. So RP TP is equal to 400. So the value of RP is 2 times RM, and the value of TP is TM plus 1. Multiplying 2RM TM plus 2RM is equal to 400. RM TM is equal to 160. So 2 times 160 plus 2 times RM is equal to 400. 2 times 160 is 320 plus 2 times RM is equal to 400. Subtract 320 from both sides. 2 RMs are equal to 80. If I divide both sides by 2, RM is equal to 40. Okay, so if RM is equal to 40, then it says that RP is equal to 2 times RM. RM is 40, so that equals 80. So RP is equal to 80. All right, so now I can use that to solve. I've got RP, TP is 400. So RP, TP equals 400. RP is 80, right? Divide both sides by 80. TP is equal to 5. So I can put that here, 5. And it tells me that RMTM is 160 RM, TM is 160. And RM is 40 times TM is equal to 160. Divide both sides by 40. TM is equal to 4. And that's correct. And that is the last of lesson 69. Not terribly hard. Excuse me, swallowed spit the wrong way. Not terribly hard, but it is a little time consuming. All right, so that's all I have for now. I will see you in the next one.